Okay, we have already studied virtualization. Next, we continue starting from what we studied before. Everyone knows that when computers were first born, up until the 90s, we actually worked in traditional data centers. In China, perhaps before 2010, we were all in traditional data centers, meaning our operations were all running on physical machines. Each physical machine ran a single application. At that time, due to various immature technologies, everything was running in the physical world. But in the physical world, many people felt that resources were wasted and it was not so convenient to manage, right? Each type of business had to set up clusters. Why set up clusters? Because once the physical host failed, it meant that the business would fail. The business would be disrupted. Back in those years, this is how we did it. For example, we would run an Oracle cluster, right? We would run a Windows cluster. We often did this. Like Windows also has special cluster components. When I first started working, I almost always did these things. So why at that time? First of all, it was inconvenient to manage and resulted in low resource utilization. Could multiple businesses run on one server? Generally, it is not recommended. Generally, it is not recommended to run multiple businesses on one physical server. Running multiple businesses is not recommended. Why? Because resources could not be isolated. Resources could not be isolated. If multiple businesses ran on one server, there would be problems between these businesses. For example, problems with resource usage. One resource using too much CPU and memory resources causing another business to run slower. We couldn't control it. Secondly, there were no boundaries between resources. That is, once one business was compromised, it might cause another business to also possibly be compromised because they were not isolated. At the same time, everyone knows that running multiple businesses on a physical server could also cause, for example, one business might need a restart to take effect. Then should it be restarted? Once restarted, it could cause problems for another business. So later, virtualization technology came along. Virtualization technology then solved all the above problems. For example, issues with resource utilization. Initially, a physical server could only run one business. Despite high configurations, it could only run one business, and it felt like a waste of resources. So after virtualization appeared, it greatly improved resource utilization, right? No need to say we only run one business on a server anymore. So secondly, it also achieved resource isolation. You think originally one server running multiple businesses was not safe. Although resource utilization was improved, it wasn't safe. So with virtualization, we could run each business in a virtual machine. Virtual machines could isolate resources from each other, right? Both ensuring resource utilization and ensuring resource isolation. Thus, virtualization has been popular for so many years. Later, everyone knows about cloud computing. With cloud computing actually manages and schedules resources through virtualization. Let's say virtualization needs dedicated management. For example, we open a virtual machine. It's not so convenient to manage. For example, we want to do elastic scaling. It doesn't have such services to support us. Even including today, we have various artificial intelligence, Internet of Things, and so forth. These kinds of services we can't implement at the virtualization layer. Virtualization can only open some resources for you. But at the cloud layer, it can help provide you with such cloud resources, providing more of what is the services we want, right? Is what we want. But with the development of time, you will find our virtualization as well cloud actually waste a lot of resources. How so? Think about it. Every time a virtual machine is opened, every time a business is opened, it consumes resources. We always need a virtual machine. We always need a virtual machine. Now think about it. A virtual machine itself occupies resources. It is actually a waste. What do I mean? For instance, when I need to start a service, I essentially need to start a virtual machine. This virtual machine itself will take up disk space. And at the same time, when I boot it up, I first need to run this virtual machine itself, right? To run this virtual machine, it might take about 5 minutes to boot up. It takes 5 minutes to start up. Now think about it. First, each virtual machine might require around 2 GB of RAM, just the virtual machine itself. It might need to use 2 CPUs. If a physical server runs 20 virtual machines, it would use up 40 GB of memory. Actually, this is not what I want. I need the services themselves, not the virtual machines. But to achieve resource isolation, we have to sacrifice performance. That is, running 20 services in 20 virtual machines. Each virtual machine running a single service. Well, the resources used by each virtual machine itself are beyond our control. We just have to accept it. If you want isolation, if you want to increase utilization, you have to make sacrifices, right? You have to give up some resources. First, you need 40 GB just for disk space, 20 GB for 20 virtual machines, each with a 40 GB system disk, which makes 800 GB in total. This system disk is also being used. Secondly, each virtual machine also occupies resources. These resources are also wasted. Now think about it. We run so many virtual machines for what purpose? It's for running services. Is there a way to achieve resource isolation without using so many resources? That's when container technology emerged. Container technology came along, allowing each business to run in a separate container on the physical machine. Container technology appeared, and containers can be run directly on physical machines, each container running a separate service, while being isolated from each other. The underlying technology used here is called namespace, which isolates by using namespaces, similar to how each virtual machine or cloud host operates. Using namespace technology, they imported this into our containers using namespace. Thus, they transferred this technology to containers, achieving both resource isolation and reducing the resource usage of the underlying virtual machines. Why not? If it reduces resource consumption. Thus, running containers on physical machines solved the first generation issue of needing virtual machines for resource isolation. With container technology, things became more lightweight. To achieve resource isolation, they used virtual machine technology. With container technology, it became even more lightweight. Each container, in fact, operates based on the host machine's operating system. It does not need an operating system. For instance, running 20 containers on a physical machine. When you start these containers, they do not need to start the kernel. They only need to start the user mode. Our entire operating system is divided into two parts, one called kernel mode and one called user mode. Kernel mode, for instance, includes loading the kernel, loading drivers, etc., which belong to kernel mode. Loading the file system, while our containers operate on the host machine. 20 containers. Each container, when started, does not need to load anything kernel-related. It doesn't need its own operating system. It directly shares the resources of the host machine. Kernel mode, sharing the host machine's kernel mode. Each container only needs to run its own user mode. Firstly, it boots up faster and saves more resources because it doesn't need each container to have its own operating system. It saves resources and thus doesn't need as much space. It doesn't need as much disk space to hold these resources. It utilizes them, increasing utilization while also achieving resource isolation, and it's more lightweight. So, from the moment it appeared, our containers have dramatically emerged. Since then, we have entered the era of containers. After explaining this, you'll find that this is indeed the case. We really don't need to install a virtual machine just to run a service. It's cumbersome and also slow to boot, right? And this virtual machine might just fail anytime. But with containers, as long as the host machine doesn't fail, our containers usually won't fail either because they only require user mode components and don't need kernel mode components. Okay, so we have officially entered the era of containers. Actually, container technology has been around since 2003. It's been a decade. It's not a new technology, but has already become very mature. And this technology first became popular in internet companies because the internet is the most willing to adopt new technologies, right? The most willing to adopt new things, especially if it saves them money. Saving money is the top priority for internet companies. Whatever saves money, they'll do it, right? Unlike traditional companies, where it's not about lacking money, but lacking stability. Our top priority is stability, like banks, right? Electricity providers, transport, energy. These sectors don't seek cost savings, they seek stability. But for internet companies, they're in it to make money. Saving money is their top priority. Of course, due to technological maturity, what I'm saying now, like banks, internet, electricity, energy, transport, they are also starting to use our containers. Because it's very mature now, right? And it's easier to manage than traditional virtualization, simpler. That's why we need to use containers. Okay? Does everyone understand what I've explained? Previously, many said they had never encountered containers or even heard of them. From what I've just explained, you should have a basic understanding of containers now. Everyone should understand what containers are for. We just mentioned we've gone through 3 generations. The first generation of physical machines, the second generation of virtualization. Why did virtualization appear? To achieve resource isolation, increasing resource utilization. But it also brought a lot of additional overhead because virtualization itself consumes a lot of resources. So, can we achieve resource isolation without running a virtual machine while running a business? That's when containers appeared. Okay. That's what we've just introduced about the origins of containers. The origins of containers. That a physical machine can run 20 virtual machines is already quite good. But a physical machine might be able to run 50 containers or even 100 containers. So why is this technology called containers? Actually, this comes from the concept of shipping containers. Everyone knows the appearance of shipping containers changed the entire history of shipping. It changed the whole history of transportation. Why do I say this? Originally, from the US to China, there was a large cargo ship, tens of thousands or hundreds of thousands of tons. So, transporting things from the US to China, like when we import soybeans, right? Or importing corn. Although China is a major producer of soybeans and corn, we still import a lot of these beans and corn, right? Because we need to develop the breeding industry, we need more land for growing food. At the same time, we import some high-tech products from the US, or electronic products, cars, pianos. But here comes the problem. Inside a large cargo ship, you need to transport these beans, soybeans, corn, and also high-tech products. At that time, stacking becomes a problem. How to stack more efficiently. At that time, we also imported oil. Originally, things piled up together were quite chaotic. Of course, you could stack them, but it definitely wasn't efficient. It could be done, but the efficiency wasn't high. There were pianos, right? And cars, and corn, and oil. Could all these appear on one cargo ship? Usually their efficiency isn't that high. But after the introduction of containers, we started to place different goods in different containers for transportation. Containers between containers then achieved isolation. And also, to ensure that the cargo ship, it can transport any kind of goods. It doesn't matter, because we have containers. Using containers to achieve isolation between potatoes, soybeans, corn, and oil. This revolutionized our maritime history, entering a new era. Thus, the invention of the container changed our entire history of shipping, right? Similarly, for us, in the world of computing, can we also, like the cargo ship transporting goods, put each business in its own container? Can containers be isolated from one another while also running different businesses within? Running different businesses, containers achieve isolation between each other. Then containers appeared, right? Containers have appeared. Okay, let's turn off the noisy one. The sound is too loud. Okay. Many people said after that explanation, then, do we still need virtualization and cloud? Will containers replace our virtualization and cloud? At least for now, no. Because virtualization has its advantages and its application scenarios. Okay, next. About virtualization and cloud, virtualization and containers. What are the differences between them? Right? We have it here. As for containers, they generally start in seconds, whereas virtual machines take at least minutes to start. Typically, containers use disk space in MB. Virtual machines usually require disk space in GB, which are in the megabyte range, just a few megabytes, tens of megabytes. While virtual machines are generally gigabyte sized, right? Performance is close to native. Virtual machines are weaker. What does that mean? It's like this. If you run a virtual machine on a physical machine, and assign the same CPU, memory, and disk to the virtual machine, its performance will definitely be lower compared to a physical machine with the same configuration. The performance of the virtual machine will definitely decline. What do I mean? For example, if I have a physical machine with 8 CPUs, 16 GB of memory, and a 1 TB SSD, and I start a virtual machine and give it 4 CPUs, 8 CPUs, 16 GB of memory, and a 100 GB hard drive, obviously the physical machine performs better, right? With the same configuration, the physical machine's performance is definitely better than the virtual machine. But if you run containers, they are close to native performance. What does that mean? It's like running an application directly on the physical machine. It uses the host resources directly, achieving performance close to native. That means whatever performance your physical machine has, the containers will have similar performance, close to native performance. So what performance the physical machine has, the container will have as well, close to the native performance of the machine. While a physical machine can usually run a few dozen virtual machines, which is already quite good, if it runs containers, a few dozen to hundreds of containers are a small case for it. I often see in many business environments that they run several thousand containers. So often when we are recruiting, many young friends come to me asking for people, asking if we have friends who understand containers well. They say their scale is okay. They maintain several thousand containers. So you see, all those previous courses, you didn't master them. But today, if you just learn about containers, you can find a job. Yes, if you learn it well, just by learning about containers, you can find a job. We have specialized container engineers. For example, I search on Boss Direct reviews. I search for jobs related to containers. I search for container-related positions nationwide. Approximately how many positions are there? Many pages. Let's take a look. You see, container development, what a container expert. You see this, there should be quite a few. I'll search a bit. Searching for containers might bring up something else. We'll search for K8s instead. I'll search directly for K8s. I just searched temporarily. HCIE Cloud offers 30 to 60K. This Kubernetes, you see, the salary is not low. You see, there are no low salaries. The salaries are all quite high. I just searched randomly. I don't have a salary, sorted from high to low. You see, the salaries aren't low. You need to understand K8s. So just by learning K8s, you can find a job. So containers, so today, because of the birth of this technology, it has significantly saved resources for businesses. For example, for internet companies, if in the world of physical machines, running a business, it would occupy an entire physical machine to run a business. Now imagine if we use containers, might require hundreds to thousands of physical machines. Then came virtualization and then the cloud. Now, it might only need 100 physical machines or 200 physical machines. But with containers, maybe just a few dozen physical machines are enough. Firstly, fewer personnel are needed. Secondly, the resources needed are less. Previously, think of hundreds to thousands of servers. Firstly, enough space in the data center was needed. More hardware had to be purchased. There was significant yearly cost and air conditioning, right? Cooling, electricity. Internet companies use an incredible amount of electricity. Just the electricity cost is enormous. Look at our i1 rack setup. We have only 6 servers. I did the math. It uses about 200 kilowatts a day. Just our rack. About 200 kilowatts a day. About 7,000 kilowatts a month. Just that rack. 7,000 kilowatts a month. Not including other costs. So each virtual machine actually has its own operating system, right? With infrastructure, has kernel mode, has user mode. But containers, they don't have kernel mode. Only user mode. It's easier. They only have applications. Just need to run applications. All right, this is the difference between virtual machines and containers. So if we can choose, we would of course choose containers. Are there still use cases for virtual machines? Of course. Why still use virtual machines? Because compared to containers, they're more suitable in some special application scenarios. Or for some applications, they might need extensive modifications. Virtual machines might be more convenient Virtual machines might be more convenient. So in production environments, actually containers and virtual machines coexist. There's no one replacing the other. It's not about one replacing the other, like containers replacing virtual machines or virtual machines replacing containers. Actually, in the same environment, you can use both containers and virtual machines. They can coexist. They can coexist. Both can coexist. Okay, whether we use virtual machines or containers, right? Both can actually coexist. And there's also a fusion between them. What kind of fusion? For example, we can run containers in a physical machine. But our management style isn't as convenient as managing virtual machines. For example, can we install a virtual machine in a physical machine and then run containers inside it? Why do that? Isn't that a waste of resources? Is the resource overhead not increased? Then why not just run on a physical machine? Because we can utilize the scalability of virtual machines. The scalability of virtual machines. Features like live migration. That is, I'm using the advantages of virtual machines and also the advantages of containers. So there are some scenarios where the underlying layer runs virtual machines. Many say, then why not just run virtual machines? What's the point of running containers? Think about it. Today, we're running on Huawei Cloud. For example, when we run a CCE, I run CCE. When you run in CCE, you can choose to have physical machines underneath, or you can choose virtual machines underneath. If you think of running a physical machine, that would be very costly. You would need at least 2 physical machines. If I say that underneath, I could. I've already run a cloud. The company has already run a cloud. Can I now, within the cloud, deploy 2 virtual machines? Can I run more containers in these virtual machines? Because each container, for example, a virtual machine, originally could only run one service. Now, like a virtual machine, can it run many services? Does it also save resources? Right? It also saves resources. All right? So we can also run containers in virtual machines, right? Because in this way, it relatively saves resources. Many people will say, then isn't the overhead bigger this way? Wouldn't it be simpler to let physical machines run containers? Why run a virtual machine in the physical layer and then run containers on top of the virtual machine? Wouldn't the performance be very poor? That's true. If you can accept the performance of this virtual machine, if you can accept the performance of this virtual machine, then why can't you accept the performance of containers? That is to say, the performance of containers is already close to that of virtual machines. If you originally ran a virtual machine and its performance met your requirements, then it's equivalent to running containers inside a virtual machine. Could it also meet your requirements? Because it's close to native performance. Just that. And there are some scenarios like this. For instance, besides Huawei Cloud, I looked at other clouds. Basically, it's like this. As everyone knows, Huawei Cloud, its foundation, has a lot of virtual machines forming. Huawei Cloud's foundation has a lot of virtual machines forming. Huawei Cloud installs various sub-modules in virtual machines, for instance, right? Our VR router, isn't it just one laid in a virtual machine, right? For instance, our Nova API, it might also be laid out in a virtual machine. For instance, LVS Nginx and some consoles, they're all laid out in virtual machines. That is, many services, they have split them up. Why split them up? First, splitting them up makes maintenance easier. Or say, if one component fails, doesn't it not affect the other components? If you put everything in one control node on a physical machine, once this has a problem, wouldn't it cause everything to fail? Just that. Okay, it installs each submodule into virtual machines. But I still haven't understood why Huawei operations use so many virtual machines at the bottom. Why not use containers? You lay each one in a virtual machine. Why don't you lay each one in a container? Isn't that lighter and faster? Look at our rack. Sometimes when I leave work, I just turn it off because electricity is also expensive at night in the indoor environment. You wouldn't say to turn it off. I come up in the morning and turn on the machine. It takes at least 20 minutes to start up. It takes at least 20 minutes to start up. But if it were running containers, This speed might save half the time, maybe 10 minutes to run. For instance, Tencent Cloud. Tencent Cloud, its foundation is all containers. Red Hat Cloud, its foundation also uses containers. These are some private clouds I've used. Their foundation, I've used their private clouds. Their private cloud's foundation is all containers, so it's relatively lighter. But Huawei's foundation is all virtual machines. You see, last time, 177 virtual machines, including that network node container. There are even more virtual machines. So I still don't understand to this day why the foundation isn't containers, but is virtual machines. Is it because of historical reasons? Because historically it was developed as virtual machines. If you think about transforming it, logically speaking, I think this transformation shouldn't be too hard, but it has always used virtual machines. It hasn't used containers. Maybe one day Huawei might release a version where its foundation is all virtual, uses containers as well, might replace all the underlying virtual machines with containers. That's also possible. That's also possible. Okay, so this is our application scenario. Let's say you want to build a cloud. You want to build a cloud. The foundation of the cloud runs containers. The underlying components are running on top of containers. Then in the cloud, virtual machines are installed in the cloud, right? Maybe in the virtual machines, containers are installed again, just finally achieving you in me in you. We made a fusion between virtualized cloud and containers. There is no longer such a clear boundary. They might, in one scenario, use both virtual machines and containers, right? Okay. This is roughly the scenario. So our foundation for building clouds might be containers, using numerous containers. Isn't that building a cloud? Right. Now, aren't we using numerous virtual machines to build a cloud? The underlying components. And in the cloud, isn't it to run virtual machines? Of course, compute nodes are not containers. Compute nodes might be a physical machine. A compute node is a physical machine, right? Our components forming control nodes. We run in containers, then install virtual machines in the cloud. Virtual machines then run containers. Okay, roughly that's the situation. Indeed, Huawei's cloud is relatively heavy. Huawei cloud is heavy. So you see, deployment takes tens of hours, and the requirements for servers are very high. And if you install just a bit more cloud service, like if you want to install more advanced services, our control nodes would explode. We would need to add more control nodes, like in this current environment. I find that after deploying the basic services, deploying something like CCE is about enough if you want to run some other advanced services like artificial intelligence. I find that the CPU of the control nodes explodes. Just our memory, 768G, 40 CPUs times 2 threads, 80 processors. I find that they are almost maxed out. We still need to add that control node. Maybe we need to add 2 more control nodes to run more high-end services. So it really is quite heavy. Containers can also do service. Container upgrades are more convenient. And containers can also do gray upgrades. This gray upgrade means that during the upgrade process, it does not affect the business. Gray upgrade. If you say, because running news upgrade is more convenient, I tell you running container upgrades is more convenient. Once you learn about containers, you'll understand. Container upgrades are like this. They have many rules. For example, I have 3 containers. That is, 1 application, 3 containers. You upgrade one of them, the other 2 don't upgrade. Once this one is upgraded, then upgrade the next one. After the next one is upgraded, then upgrade the next one. And the entire service continues without interruption. Okay? This is the relationship between containers and virtual machines. So, there is no scenario that says I only use containers to replace all virtualization. Nor is there saying we only use virtualization and don't run containers. Of course, are there enterprises saying I only run virtualization and don't run containers? There are. But saying I completely run containers and don't run virtual machines, that basically doesn't exist. That basically doesn't exist. Okay? I think if from a technical level, changing Huawei Cloud's foundation to containers would be no problem at all. It's definitely possible. It often hangs, doesn't it? Virtual machines are more stable. Containers are unstable. This is not. In the internet, actually, everyone plays like this. Now look at the internet you use. You use WeChat, right? You use JD.com. You do live streaming on Douyu, including the carrier, China Mobile. What I understand, their foundation is all containers, right? Today, the services you access are all running on containers, saying it's unstable. So don't use it. This explanation definitely can't be justified, right? This might need a process. Okay, so we've just introduced the advantages of containers, right? Why use besides this, containers? Just like just said, deployment is more convenient, and containers can be more easily packaged into standardization. Everyone knows, migrating virtual machines actually has a problem. Like today, moving a virtual machine from Vermont into Huawei, isn't there a need for specialized migration tools, right? Just like this morning, we used Rambo to migrate. It can be migrated and also convert disk formats. But relatively speaking, it's not that lightweight. But containers can package the entire container into a package, pack the entire container into a compressed package. This compressed package can run in a new environment very conveniently. He said it like this: container portability is also very convenient. You see, containers are a lightweight, portable, self-contained software packaging technology. Applications can run almost anywhere in the same way. How to understand this? For example, today you test an application in your production test environment. After testing, it works fine. Finally, you deploy it to the production environment and find it doesn't work. This kind of situation we often encounter. Or say we run CentOS 7.5 in our test environment. The test environment is 7.5. And run it on CentOS 8. The CentOS is 8. Done. Like a while ago. Our buddy did experiments in Rocky 8, researched for a week, then the client switched to Rocky 9. Go back, their system is Rocky 9. Found out on the first day, totally lost. Found it different from 8. Maybe even where some config files are different. He was baffled. That wouldn't exist if it was a container. I made a container in my CentOS 7. After packaging it, I put it in CentOS 8. It would run just fine. So these applications can run almost anywhere. In the same way, virtual machines can't, because virtual machines have too many compatibility issues, right? It might lead to not being able to run. And developers in their own computers create and test the containers without any modification. Can run on production systems, virtual machines, physical machines, and public clouds, right? So if at this time you're doing experiments, you want an environment, you apply for a cloud host on a public cloud. Can also run all container experiments. Containers grant software independence, making it unaffected by external environments, such as differences between development, testing, and pre-production environments. Just saying I was fine in the testing environment. But once it gets to production, it's different. Causes all sorts of problems. Containers don't have that issue because they only include their stuff. Doesn't it not need any kernel level stuff? The things it packages, aren't they unrelated to the kernel state, so it's not affected by the outside, thus helping to reduce conflicts when teams run different software on the same foundation? That is, to avoid such problems, right? Very convenient, right? Pack it wherever you want to use it, and regardless of where you previously packed it. And also, irrespective of your underlying host's operating system version. That's very convenient, right? Virtual machines, you still have to consider many factors. Say, whether Zen can be migrated to KVM, whether WordMod can be migrated to KVM, right? You have to consider various factors and various compatibility issues. Which operating systems are in the compatibility list, which are not in the compatibility list, because after all, they still have to do file replication. Then do you still consider specific files? This migration definitely isn't as convenient as containers. Today we talked about Rambo migration being very smooth. Actually, in a different environment, there might be various inconvenient scenarios. But containers don't have these problems. So after learning, you'll find, wow, it's so convenient. You see, this is the kernel, right? You see, it runs various containers on top. Each container runs different services. Each container runs different services. So we run many containers here. Why does he make this container into such a thing? Is it the concept of a shipping container? The concept of a shipping container. He made it more playful. He changed that cargo ship into a whale. A whale, not a dolphin. Changed it into a whale. And then it carries many containers on top. That's the gist of it. So this is the concept of containers. It's like a shipping container. Very convenient for transporting goods. Just like containers can be easily moved and deployed in different environments. So containers, their English name is container. In English, it actually translates to shipping container. In Chinese, we translate it as container, right? Translating it as shipping container might feel a bit old, a bit low, so it's translated as container. This makes it easier to understand. Okay, so containers provide software with tremendous portability. Tremendous portability. After you learn it, you find containers very convenient. Very convenient. Okay, now comes the question. Many people say, what about containers? We just talked a lot about them. So, what containers are there? Well, first we need to talk about the progenitor of containers, Docker. We need to mention the progenitor of containers, Docker. Docker was developed by a company called .cloud. It started as an internal project and was launched in 2013. Developed in Go, which was open sourced by Google. It was developed using the Go language. So because of the birth of containers, it spurred the popularity of Go language. Everyone knows the popular languages now like Java, Python. The rise of Python is because of the advent of cloud. Everyone knows OpenStack was developed in Python. And Java is very traditional. C language is even more foundational, generally used for embedded systems. Then came Java. Later, because of the rise of the cloud, Python became popular. Including today's artificial intelligence, many algorithms are written in Python, which has spurred the popularity of Python. Later, the emergence of containers spurred the popularity of the Go language. Okay, so containers actually originated in 2013. Someone just mentioned that state-owned enterprises and the financial sector are relatively slow to adopt new things. For example, we had virtualization technology very early, but it took many years for the financial sector to start using virtualization. They waited until it had been used in the industry for many years, found to have no problems, and was very stable before the financial sector began to slowly adopt these new technologies. Why is that? Because a technology that hasn't been tested over a long period of time, I don't know if it will have future problems. And for the financial sector, the biggest requirement is stability, reliability, not necessarily saving money, but stability and reliability. They need something that's been tested and proven over time. So without long-term accumulation and testing, they wouldn't dare to market it. Like a vaccine hasn't been developed over a long time. Like developing a vaccine might take 10 years or even longer. Except for the COVID vaccine, in reality, it takes a long time, requires extensive testing. Phase 1 and Phase 2, human trials. Phase 1, mouse trials. Phase 2 involves human trials. Phase 3 is market deployment, conducting extensive testing, finally stabilizing. Similarly, the financial industry also treats new technology development like vaccine development, needing a certain maturity before adoption. They won't use it otherwise. So once the financial sector can accept something, it means the technology is very mature. That's why they use it. Otherwise, they wouldn't. So 10 years later today, right, the financial sector is also starting to use container technology. So it started back in 2013. Actually, the company wasn't originally called Docker, it was called Docker Cloud. Later, because the Docker product became so popular, they changed the company's name to Docker. So who owns Docker? It belongs to the Docker company. So Docker is whose? It's owned by the Docker company. Originally, it wasn't named this. So Docker is owned by Docker, Inc. It was initially not called this because of the popularity of its container technology. Docker is a lightweight virtualization solution based on container technology. Okay, it's like this. Docker does not equal containers. Docker is a software and solution that implements container technology. Just like today's cloud computing, OpenStack does not equal cloud computing. OpenStack is one of the most well-known solutions for implementing cloud computing. Besides OpenStack, there actually are others, right? Before OpenStack, there was CloudStack. So, we have many solutions. Docker is the same. Docker is one of the most popular container solutions in the world of containers. So it's not that containers are synonymous with Docker. It is a solution for containers. Okay, moving forward, various manufacturers have also developed similar container solutions. For instance, Red Hat has Podman. Apart from Docker, we have another one, Podman, which is also used to implement containers. Huawei uses Containered. Huawei's underlying operating system is Euler, and Euler uses Containered for containers. So in fact, there are many technologies to implement containers. So possibly because Docker was one of the earliest in the field and has the biggest name, Docker has a very big ambition. What do they want to do? They want to dominate the market, to establish their own standards and dominate the market. They might even become proprietary in the future. So the company also developed a software specifically for container orchestration. Their company developed a specific software for container orchestration called Compose. It's like this. Their company developed Compose, which is very ambitious. They want to dominate the container world. And as they became more outrageous, they might even start charging in the future. So Google couldn't stand it anymore. And developed a software specifically for container orchestration, which we all know today as Kubernetes. Developed by Google specifically for container orchestration. We have a specific certification called CKA. CKA is the Kubernetes certification. Kubernetes, because the word is hard for beginners to spell, often misspelled. So the industry later abbreviated it as K8S. K8S, which means there are 8 letters between K and S. So it's abbreviated as K8S. Count them. 1, 2, 3, 4, 5, 6, 7, 8 letters between. So we abbreviate Kubernetes as K8S. That's how it came to be. It's specifically used for container orchestration because Docker was too overbearing. So Google announced a few years ago, we no longer support Docker. Our K8S no longer supports Docker. To this day, we still use, so K8S is an orchestrator, but can we use other technologies underneath? We can use other technologies, similar to what? Docker was originally just a single machine version, similar to VMware's VMware Workstation. Isn't it just a single machine version? You think a single machine version could play? It can't play. So then came K8S. K8S you can understand as a cluster version. Just like our VMware has enterprise-level virtualization, and Huawei's isn't Fusion Compute an enterprise-level virtualization? And while Docker is a single machine version of containers, K8S is a cluster version for resource scheduling. K8S itself does not bring containers, it only does scheduling. Similar to OpenStack, it doesn't provide resources. Isn't it just doing resource management and scheduling? That's the idea. Okay, K8S is from a God's eye view. It can realize, for example, how does it work? For example, it can do a replica mechanism for containers. For instance, it can automatically set up 3 replicas. What does 3 replicas mean? It means it has 3 physical host machines underneath. So one container can have 3 replicas, meaning that the container can run on 3 different host machines. So if any host machine fails, it doesn't matter. It can also achieve something similar to the HA functionality in virtual machines. If one host machine needs to be upgraded or maintained, the container will be rescheduled to another host. Techniques like this make it much more convenient than virtualization. It's more popular, more artistic, more creative. So why would you not use containers instead? Docker is just one type of container technology, not the only one. We have many technologies that implement containers, and Docker was the earliest. Google developed a specialized container orchestration solution called Kubernetes, or K8S. Kubernetes can support Docker and other technologies as well. Kubernetes is not limited to Docker alone. So that's the information. This is about our scheduling technology, the relationship between K8S and Docker. This is similar to how you may have enjoyed playing with Workstation, thinking virtualization was awesome. Then, after using enterprise-level virtualization and cloud services, you realize that the single machine version of Workstation is nothing. It's just simple. Compared to K8s, isn't it much more powerful and complex? That's the idea. Everyone understands this. It's like when I was studying, I spent many years in the world of single machines. Back then, the internet wasn't as developed as today. I started college in 1999, studying computer science in 2000, 2001. At that time, I thought, wow, I seem to be very good at computers. Because back then, I was just in the world of single machines. Then I entered the world of the internet. One computer turned into 100, 1,000 computers. I entered the world of the internet, and I discovered he has a much bigger world outside, not just a world of one computer. I used to think I was really good, but then I came to the world of the internet and realized, wow, he is incredibly powerful. Like one person becoming 1,000, not just a matter of scale, not just one machine becoming 1,000 machines, but he becomes everything is possible. His possibilities just keep growing. Right? So this is our Docker and K8s relationship. So when you're looking for a job, you say, I'm searching for a Docker position. Is that okay? Maybe Docker positions are fewer, and you should be searching for K8s positions. So this part of the job search, we've only searched a part of it. For instance, you can just search for Docker, so you can search for Docker as well. So everything you search for is somewhat one-sided, because in the search, it might just be Docker. Look, Docker. Huawei is hiring, all looking for Docker engineers. Docker called K8s, see? Docker. You can also search K8s. You can also search, is it refreshed yet? Kubernetes, ES this. Kubernetes, see here. You see you search K8s, search Kubernetes. Both have related positions. So what exactly do you search for? It's actually all the same. For instance, I also search for containers. Don't get other types of containers mixed in. This pressure container, definitely not related to us. So you can. It's all possible. So think, this job position is much more, and the salary is very high. So I said, when you are job hunting, you set K8s, still not refreshed. Kubernetes, this Kubernetes. See here, when you search K8s, search Kubernetes. Both have related positions. So whatever you search, it's actually the same. For instance, I also search containers. Let's not get other types of containers mixed up here. This pressure container definitely has nothing to do with us, but you can do it. Everything is possible. So you see, this job position has a lot more, and the salary is very high. So I say when you're job hunting, you pick Docker or K8s. Just set it right, and you'll be fine. Okay, many people ask why you are discussing this today. Does this have anything to do with our HCS? Next week, we will discuss our cloud CCE technology. How can we discuss CCE without a foundation in containers? How can we talk about it? There's no way. Our exam's key points. HCIE Cloud Computing 3.0. Focus heavily on CCE. There are 3 questions on CCE. So once you finish studying CCE today, you can take the exam. You'll find that if you set it right, the 3.0 exam is even simpler than 2.0 because it tests more cloud services rather than having to install virtual machines, etc. I also really don't like deploying that desktop virtual machine. That template, it's actually quite annoying. So deploying on cloud services like CCE makes everything simpler and more streamlined. I didn't really like deploying that desktop virtual machine.